I can't have my calculator, I will use a computer, because I am determined to show you this in a way that you can fully understand what's going on with these graphs that he's showing you and these tables and how the average change works, okay? So, let's start by saying that there are two kinds of graphs you will often see. Please excuse if you hear Panger. She's going to scream until someone gives her attention, and I cannot do that right now. So, first off, we have these equations with a squared power. So this is y equals 1/2 x to the second power plus 2. That looks like this. This is a parabola. Goes down, curves here, goes up. It's not straight down and up. It's a curve. This is a parabola. There is one bump. One thing to note with these kinds of problems, or any problem, is that you see how x is equal to 0 and y is equal to 2 here? It's because here, 2 is the y-intercept. That's always going to be the case. The number that is just plus 2, plus 4, plus 5 million, that is where the graph intersects with the y-axis. So if I felt like getting rid of that 2, if I just did this and graphed it. So this is now 1/2 x to the second power. It moved down 2 blocks, and now the y-intercept is at 0. 0, 0. This is origin, right? So we are adding that plus 2 back because we're going to work with the plus 2 because I want to. Okay? So this is our graph. This is the parabola. This is what you will see when you get a to the second power, right? Second power. The kind of thing you'll often see. This is compressed algebra. This is not what I wanted. The other thing you'll see is y equals x to the third plus 2x to the second minus 3. You'll get a graph like this. This fluctuates a lot more. It goes up and curves, and then goes down and curves, and then goes all the way back up, right? Now here, I'd like to point out once again that the y-intercept is at -3. See that there? See that there? The number that's end right there will be the y-intercept. You may have learned that before. I just want to reiterate, okay? So this fluctuates more than the other one, doesn't it? So the idea is, if you want to find the average rate of change from, let's say, x equals -1 to x equals 2, which is all the way up there, right? If you wanted to see the average rate of change there, you can't just do it by looking at this graph due to the fact that it's not just a straight line. There's no straight line there. There's no average rate right now. It's just this floofy thing. It goes up, down, and up. It fluctuates too much for you to be able to visually see, right? However, the idea is that we want to find what the slope is from this point right here to this point right up here, right? If we were to draw a line that shows that, it would be straight. And that is the average rate of change. This uses a kind of equation you may have seen before. We will get to that, okay? Now, I don't want to work with this problem. This problem sucks. I just put in random numbers. So, we are going to get rid of this. I just showed you to show that how it fluctuates and why it is that we have to find the average rate, and we can't just pull something from the problem. We have to do math, right? We're using this one because this I made the numbers easy because I actually looked at the table. And look at this, okay? So, if we want to find the average rate of change from the point from x equals -2 all the way to x equals 4, it's up here, we needed to start writing stuff down. So, there are two ways to look at this. So this is the equation, right? This is the equation, y equals 1/2 x squared plus 2. So there's two ways to look at what it's asking. Now, there are two kinds of surrounding things, I forget what we call them, sorry, that you will see. You will see brackets, and you will see parentheses. You've probably learned this or not. Either way, here's a review. Brackets mean that you include it. You include the numbers that are in there. So if you were to look out on the graph, so this is -2 and this is 4. Include both of the numbers in your math. If you saw -2, 4 in parentheses, it would look more like that. We do not include those numbers when you have parentheses. Another thing to note is that if you ever see infinity in a problem, infinity is always with the parentheses because you can't include infinity. Infinity goes on forever, okay? There's not a point that's the infinitieth point. That's not a thing, all right? Another way that we notate it, other than the brackets, so if you're going to look at -2 and 4 on the x, right? Another way to look at it. -2 is less than or equal to x, which is less than or equal to 4. Okay? This is the equivalent of having the brackets. So -2 is less than or equal to x is less than or equal to 4. In order to write this one in that sort of notation, it's -2 is less than x is less, that is another x. -2 is less than x is less than 4. So, the less than does not include the point. The less than or equal to includes the point. This is just review or something to look forward to later. This is something that's really important to pay attention to. So, to reiterate, because I want to make sure that I'm actually explaining things well without going on nonsense tangents. Brackets include the point in your math. Less than or equal to. Always that sort of sign. Parentheses. You do not include that point. It's an open circle on a graph. It's less than. There is no equal to there. Whenever you have infinity, you always use a parentheses because you cannot find the infinitieth point. This does not exist. Okay? So, if looking at the range between -2 and +4, all right, what is the average rate of change between here? And again, we can't just look at the graph because it goes down, then it swoops back up. So, the easiest way to start is to do the math for these points. Find out what the y value is if x is equal to -2, what the y value is if x is equal to 4. We could just look at the graph, but you probably aren't really looking at graphs, are you? You're doing math by hand. So we are going to start by doing math by hand. So this is the equation, right? Y equals 1/2 x to the second plus 2. Right? So y, whenever you do math, you always start by rewriting the formula. gets it in your head exactly what's going on. And if you wrote the formula wrong and you got an answer that's correct for the formula that you wrote down, but it's not the formula you were looking for, if you were to take a test in person, you'd get partial credit because you did the math correct for what you wrote, even if that's not correct as to what you meant, okay? So y equals negative 1/2 x to the second plus 2. Let's start with the negative 2 point. So we bring the y down with us. Y equals 1/2 negative 2 squared plus 2. Okay? We're going to do this math. Hold on. Something screwed up. Okay. So, one thing to note is that if you have a negative number in parentheses when you're a negative number in the parentheses with your exponent, you include the negative. I'll show you why in a second. You probably know this, but just as a review. So negative 2 to the second is equal to 4. So y equals 1/2 times 4 plus 2. That's a good thing to start with. Now, just as a review, or just so you know, if you did a calculation and you did negative 2 to the second, you would get negative 4 because the calculator isn't connecting the negative to the 2. The only way to connect them is by putting them in parentheses. That's why you write it with parentheses, so that you know the negative 2 is part of something that's being multiplied, well, being used with the exponent. So 1/2 of 4, we know that. Yeah, 1/2 of 4, we know that. Y is equal 2 plus 2. 2 plus 2 is easy. 4. So when x equals negative 2, y equals 4. We can check this on our graph. You don't need to do this, but it's helpful to do so. When x equals negative 2, y equals 4. This is what this means. Okay? Next, we want the other bound. We want the other parenthesis, bracket. So now we want 4. So once again, we start by writing down the equation. After that, we substitute in the x value. Y equals 1/2 4 squared plus 2. See that? Now, 4 to the second power, it's 4 times 4, 16. Y equals 1/2 times 16 plus 2. That says 6. 16. Half of 16, y equals 8 plus 2. Y equals 10. So, when x equals 4, y equals 10. You got both of these math done. We can look at our graph and see that when x equals 4, y equals 10. Right? Now, how do you find the average change now? Great way to start is by making a graph of the values that you just found. So if this side is x and this side is y, x is equal to negative 2. We know that y equals 4. If x is equal to 4, we know that y equals 10. Now here's the formula I said that you may have seen before. y1 I can't believe myself. Scratch that, please. The formula you may have seen before is y2 minus y1 all over x2, that's an x I promise, minus x1. So what did this mean? If we were to substitute in the numbers that we have, so if our equation is y2 minus y1 over x2, that's an x I promise, minus x1, see that? This is our equation. We want to substitute these values in. This would be y1, this would be y2, this would be x1, and this would be x2. Go down here. So, looking at our graph, y2 is 10, meaning y1 is 4, over x2 is 4, and x1 is negative 2. So, 4 minus negative 2, which actually means that we are adding 2. You can't subtract a negative. Subtracting a negative makes a positive. 2 negatives make a positive. So, 10 minus 4 is equal to 6, right? And 4 plus 2 is also equal to 6. 6 divided by 6 equals 1. Your average rate of change for this problem between x equals negative 2 and x equals 4 is 1. Okay? This is an important equation to look at. It's important to figure out both sides of the bounds. It's important to remember that brackets include the number. It's important to make a graph of your findings and use the equation to get to the solution. There was something else I was going to say. Hang on. Oh, duh. And so once you find this is a positive average change because there's no negative there. If this were going to be negative 1, this would be a negative average rate of change. Okay? So that's how you get there. I can do another problem for you if you need more explanation, or please message me if you need something clarified. But that is the best I can do right now with my spazzy brain and the information that I can give you. I can obviously give you more later if you need more help than this.